Hello everyone, this is Vijay from simulationHub team. In this video, we'll look at how to rerun the simulation. Now, what is the need of rerunning the simulation? The main need of rerunning the simulation is to answer what if questions. For example, let's say I want to change the flow rate or velocity at the inlet. Let's say I want to change the pressure at the outlet and see how exactly flow behaves. And I want to see if the openings are changed. For example, if there are multiple inlets, if I close one of the inlet, what would happen? So there are many what if questions that a designer needs to answer. So rerunning the simulation will help designer to evaluate the performance under different set of boundary conditions. The another typical need of rerunning the simulation is to improve the accuracy. So there are different mesh settings or resolutions available on simulationHub. So rerunning the simulation is required if one wants to change the mesh resolution. Now let me use an example which we have seen before. Everybody is aware of this example. In this case, what I want to know is the flow circulation inside a house. Wind is flowing with 2 meters per second velocity. And in this particular setup, the door was open, this window was closed, and the kitchen and room windows were open. And the objective of that simulation was to see how air moves through the house. Now let's say that the window which is facing the wind is not closed. I want to open that window and see the effect. The other boundary conditions are same. It means the front door is still open. The kitchen and room windows are still open. The only difference which I would like to see is if I open the window facing the wind, how exactly flow would move through the house. Now as we have understood what are the changes that we need to do, now let's see how we can rerun this simulation with these different set of boundary conditions. So I have logged into my account on simulationHub and this is my dashboard. What I want to do is I want to rerun this particular simulation by opening the window. Now typically the first stage of rerunning the simulation is to create a copy of the original simulation. Else the original simulation data will be lost. So let me open this particular simulation. Now you can use a copy simulation button to create a copy of this particular simulation. Let me give some name to this new simulation. Let's say version 2.0. And I will click copy. Now what it does is it creates a copy of this particular simulation along with the results. So once the copy of your simulation is done, it will appear on your dashboard. So this is the copy, my first simulation version 2.0. Now to edit the boundary conditions, let me open this simulation. The time required to open the simulation will depend on the complexity of the model as well as the amount of results available in the simulation. Let's see the previous results. If you see, this door was open in the original simulation and these two backside windows were open. And you can see the flow path lines in that particular simulation. Now what we want to do is we want to open this particular window also to the wind flow. To view or edit any of the stage, you have to use View Edit Stage drop down available at the left top corner. You will see all 5 stages of a simulation on simulationHub. You can jump to any stage that you want. For example, let's say you want to replace the geometry. You can go back to the geometry stage and replace it. In this case, what we want to do is we just want to change the definition. We just want to change the boundary conditions. So I will jump to the definition stage. Now you can see that the definition stage is active. You can redefine the inlets, redefine the outlets. You can also view the definition. Now if you want to remove all the old definitions and recreate the new one, you can click on clear definition. But if you just want to add one more inlet or one more outlet, you can maintain the available definition and just keep adding the another inlets and outlets. So let me just see what are the definitions currently available on this particular model. I will click on view definition. Now you will see that the pressure at this particular outlet is 0 Pascal. The pressure at this particular outlet is 0 Pascal. And the velocity at this particular inlet is 3 meter per second. Now if you see, this particular window is treated as a wall in the previous simulation. In this simulation, we want to make it inlet with 3 meter per second velocity. So let me go to definition and define inlet. Once you click on the inlet, it may happen that you will see a stage editing dialog. This is because we have copied the simulation in which results were available. Now as you are editing this stage, the message says that the downstream stage data would be deleted. It means the results would be deleted and you have to rerun the case to get the results. As we are going to add one more inlet, we would like to rerun the case. So I will say accept. And then I will select this window face and add 3 meter per second velocity there. Now if we go to view definitions, now you will see that this particular window opening is open to the wind and velocity of 3 meter per second is provided on that particular window opening. The other boundary conditions are still there, which is door is open to the wind with velocity 3 meter per second. And backside room and kitchen windows are open to the atmosphere. So we have now redefined the boundary conditions. We made that window open to the wind. Now let's submit this simulation. The procedure of submitting the simulation is same as before. Air is fluid and we would like to run it for a coarse mesh. If you want to change the mesh resolution, you can select either coarse or medium from this drop down list. I will maintain the coarse mesh resolution because that is what we used for previous case also. So with this setting, I will submit the simulation. The time required to finish the simulation depends on the complexity of the model. Once the simulation is completed, you will get an email notification. You can wait here in the simulation viewer or you can go to the dashboard. Now on the dashboard it says that this run simulation stage is running. Once it is completed, this particular button will become green and then you can open the simulation results. So the simulation is completed now. You can see that the run and the results are marked in a green color. Once the simulation is completed, I also get the email notification about it. So let's open this simulation and see how exactly results looks like when we open the window. So let me hide this top cap, and now you can see that the flow lines are also coming in from the window. I can go and look at the values. So now you see there are two inlets, inlet 1 and inlet 2, and there are two outlets which are window openings for kitchen and the room. You can see that the inlet 1 has more mass flow rate because of area of opening. The area of opening of the door is more, and the mass flow rate coming in from the window is less, as the area of window is smaller compared to the area of door. Let's also look at few of the cut sections. Let me move this cut section bit towards down. So what you are looking at the pressure contour. Let's switch back to the velocity contour. And in this velocity contour, you can see that the flow is also coming from this window, mixing in nicely with the flow coming in from the main door. And this combined flow is then getting divided into two sections. The majority of that section is going in the kitchen room, and the other section is going in the other room. You can also see other cut sections. Let's see X cut section. Let me hide the main cut section. And hide the top cap. So you can see the flow is coming in from the window as well as the main room, mixing in nicely, and looks like there is a good circulation of air in kitchen and a room. Although these corners would be affected because there is no direct flow of fresh air. So at any point you can take a snapshot of this result. So this is how you can rerun the simulation by changing the boundary condition. Thanks for listening to this video. If you have any further question, feel free to contact us.